Welcome everyone. Let us begin. Is this pink door seeming familiar to you? If this thing appeared in our world, it would be the most convenient thing you ever had. How do we use it? Just tell it your destination, open the door, and you're just a step away from it. Although it's a fiction invention, what if someday this has become a technology product in our life? Just a command, we can travel between space instantaneously. Let's imagine, every day, our usual transportation is teleportation. You don't need a road to go anywhere. Map navigation will become outdated. Terms like distance and traffic congestion disappear from our cognition. It is an absolutely perfect way to travel around. However, based on the state of the art, they are still neither technically nor scientifically possible to human. Even though you might realize how far are we from the mouth of transportation. Engineers are researching and figuring out how to minimize the travel time and increase the capital of travel distance between spaces as much as possible. I am Chong Yao from the University of Southampton, Malaysia. Today, I'm going to talk about how far could we go in transportation. I will introduce to you two futuristic inventions in the field of transportation. Let us look forward to them because they are going to be real in the future. As we know, the human body is not designed to stay static all of the time. We have a muscular leg. We could walk, sprint, and squat to move anywhere we would like to. Human ancestors could hunt for food and don't get starved to death. Even so, curiosity is an essential spirit amongst humans. The ancestors want to explore more about the world they are living than just a stone's throw away from their shelter. Our legs are no longer fulfilling us. This motivates us to figure out how to get faster, further, and safer to anywhere we want. There are horseshoe, wheels, wagon, engine, and many other more. These parts are invented in the evolution of transportation. Nowadays, because of success in the development and advancement of transportation, the world has become borderless between countries. People can travel effortlessly and safely. Distance is no longer a problem for humans. Human no longer needs to walk or run to any destination as there are a lot of options. We are all the fortunate ones. We enjoy this technology every day in our life. We have a variety of choices to travel around. Like cars, most of us have a driving license. The ship for a great vacation. Aeroplane, attending a business conference, and train to visit your hometown. These are the four examples of transportation, but they also symbolize the four modes of transportation: roadways, waterways, airways, and railways. Have you ever asked yourself, how vital is transportation in our life? I would say transportation is how we build our network, exchange, trade, and communicate with others. It is the first step to establish globalization. Here is a graph showing the number of registered vehicles from the previous decade until 2011. And this is the graph of the number of domestic flight passengers from 2003 to 2015. And this is from Indonesia. As we can notice that there is an overall increment throughout the years. Furthermore, we have a graph of operating cruise ships in Asia and the South Pacific region from 2004 to 2024. It is predicted that the trend will continue as long as people want to enhance their quality of life. The production of the vehicle in the industry is still increasing. The requirement is always on demand, and the usage of vehicles is again rising continuously. So we cannot deny the mobility that transportation brings to us and society. The recent pandemic, COVID-19, has limited transportation availability due to the numerous lockdown of countries and travel restrictions. Enormous implications have been caused by the coronavirus on global economic growth. it is very inconvenient for today's world without the presence of transportation. Today, I would like to talk about two innovations which have the potential to be a singularity in the field of transportation. Both of them are feasible technology. Could you guess from these two icons? Okay, let us win back the time to 1960s. After the first lunar mission, we realized that the Earth is actually just a borderless blue sphere. Space exploration became a popular subject on every science pioneer during that era. However, until now, to travel or to carry anything into space, the only way is through the rocket. Most of them are chemical powered, and this is its structure. Okay, let's simplify this. Much better. Okay. So rockets are mainly made up of four components: the guidance, payload, propellant, and structure system. Our ultimate goal is just sending the payload and guidance system into space, which is only this part. Where the rest, the propellant systems, as well as motors and supporting structures, are abandoned after the burn-off to reduce the overall weight of the rocket. C. Lots of infrastructure will be wasted during the staging process. Statistically, it is more than 90%, just to ensure the thrust could overcome the drag and gravity. That means most of the energy is dissipated unintentionally and results in becoming an expensive but poor efficiency system. Even the latest reusable rockets will throw away over 75% of its initial mass. The good news is there is an innovative planet-to-space transportation system being introduced in 1895, and that is the space elevator. It is envisioned that the cost of transferring artificial satellite and astronaut to space will be reduced up to 1,000 times and will be more reliable in terms of safety measure. It will certainly be a game changer in the economy of space industry. That sounds pretty good, but during that time, it only appears in engineer imagination because there is no material qualified for the cable or the tether. It must be lightweight and has incredibly high tensile strength. Such high specific strength is unlikely to manufacture at that technology level. Until our technology could be conducted in nanoscale, as known as nanotechnology. Nanomaterials such as carbon nanofibers able to withstand its own weight as well as the climber additional weight. It is 100 times tougher than steel and has plastic flexibility. This supernatural material can be the main tether composition, and it has enlightened us to once again believe in the possibility of the space elevator. So how does a space elevator work? Okay. Thinking of a ball is attached with one end of a rope. In this analogy, the ball is a counterweight, and it could be a satellite. The rope is the carbon nanotubes composite tether, and the center is the Earth. We know that if we rolling this circularly, the centrifugal force will stretches the rope out to its full length. Back to the real case, a stationary land or oceanic-based platform is built from the Earth's surface, reaching to the height of geostationary orbit. This is the draft design of the Earthport. It should be isolated and have the maneuverability to avert high winds and falling space debris. A geostationary orbit is an orbit that has the same rotational speed of Earth equator. It is approximately 35,000 kilometers with us. If there is a satellite revolving on the orbit, it will be relatively static with the equator. The tether will first be installed on a geostationary satellite and dropped until it reaches to the equator surface. The tether will be anchored on the base platform. Next, we have the climber. There's a wide range of designs, but it will not have the same structure of the elevator in common sense. It is still a controversial topic about how the climber should ride the cable. For now, developers propose using electromagnetic mechanism or roller. Additionally, to maximize the work rate, light climber is more preferred and would be sent several up simultaneously, with the pace at correct timings and to minimize the cable stress and oscillations. About its electric power system, there are several methods to pull up the climber while it's rising. It could be wireless energy transfer, but this is pretty much difficult to achieve as it needs to travel wirelessly up to 10,000 kilometers. Storing high specific energy such as nuclear energy, it works but in a risky way. Solar energy, the solar panel could be installed around the climber, but it only could be functioned under optimal weather condition. There are pros and cons among these options, so examination is still being done at the current stage. The energy is not supplied throughout the whole elevation. Once it has reached the geostationary orbit level, there is no more gravitational pull on the climber from the Earth. The motion will be consecutive due to the centrifugal force. Just a deceleration needed to apply once it reached its destination. The center of the mass of the whole system should be above the geostationary orbit, around here, or else it will be collapsed like a free body. So the tether extends from the opposite side of the geostationary satellite until it reaches the counterweight. It can be a spaceport or an asteroid. Here the LEO means low Earth orbit while the HEO means high Earth orbit. Compared to rockets, a space elevator would be a less expensive, quicker way to get payload and individuals off Earth. Because the difficult part, which is taking off from the ground, has abridged. Currently, due to Japanese researchers' deep proficiency in the field of carbon nanotube technology, Japan's space elevator companies is actively researching and experimenting. They have successfully determined the construction procedure and came out a schedule for it. Let's translate this. Okay, good. From the figure here, we will see that it will take up to 20 years to manufacture the cables, and another 18 years with more than 500 times of reinforcement, it could handle up to 7,000 tons climber. The climber has started to manufacture since 2012. Same with the geostationary station and Mars Moon Gate. In this year, the construction of Earthport has started. As you can see from this figure, there are different stations and gates along the tether. One of the Japanese space elevator company, Obayashi, planned to complete a space elevator project in 2050. Everyone could depart from the Earthport to the geostationary Earth orbit station terminal, even for vacation, they said. The space elevator will not only be beneficial to astronomers, but it could also fulfill people's space traveling dream. What about a dream is about traveling in a tube without blockage? Is anyone have a dream like this? Because I'm going to move on to my next topic. Do you still remember the 4 modes of transportation I mentioned earlier? Now I will introduce the 5th mode of transportation, which leads to my second topic today. It is called a Hyperloop. It's a low-pressure tube system which could let a capsule to travel in an environment with negligible air resistance. How fast could it be? In theory, the result of its speed could reach 1,220 km per hour. And this is 10 times faster than a driving car on a highway. And it could carry either goods or humans. What? Isn't it too dangerous for a human to travel that high speed? Or can we even adapt to that? Well, it's actually similar to what you feel inside an aeroplane. The capsule accelerates until it gets to that traveling speed. You won't feel you are moving faster than a Boeing aircraft due to law of inertia. Other than that, many safety measures have been considered. The pipelines will be constructed by thick steel that is difficult to break or puncture. Additionally, they are engineered to maintain their structural integrity. There is also an emergency system that could repressurize sections when there is any sudden influx of external air. Sensors are installed along the road, so if there are issues, it will report immediately. Nowadays, there are constructions of a tunnel network for Hyperloop in cities of the United States. Hyperloop company are researching and testing in their various program currently. If a global Hyperloop network is installed on the Earth, people could travel anywhere within half a day. There are two mechanisms to achieve this transonic speed: the application of magnetic force and the depressurized tube. This is an electric motor, consists of stator and rotor. The stator is made of electromagnets. When there is an alternative electric current, as known as AC, passes through the coil around these stators, from the side view, there are rotating magnetic field produced around the stators, indicated by brown arrows. There will be a change in magnetic flux across these rotors. According to Faraday's law, magnetic flux change provides electromagnetic force and induced current in the surrounding coil of the stator. Then a rotating Lorentz force is created too. For the Hyperloop case, instead of circular stators, the stators were installed linearly, as shown. At the same time, the rotors are also installed linearly on the pod. Not rotating force, but a repulsion force will be created. This force pushes the capsule consecutively, and a compute electrical system controls it to accelerate or decelerate. Next, we have magnetic levitation. This is an arrangement of permanent magnets named Halbach array located on the pod. This configuration combines the magnetic flux, induced producing more powerful magnetic field strength on the bottom side. In contrast, the upper side is eliminated without changing the magnet properties. On the other hand, the track will be manufactured by aluminium. It's a conductive material, so when there is a magnetic field changing over its surface, eddy currents are induced within the surface. Mirrored magnetic field is produced instantly. The pod and the surface will repel, and this is why the capsule could be float on the air. Compared to the maglev train we have right now, the Hyperloop system will be more efficient by minimizing the power infrastructure. Okay, second one. The capsule must stay in a depressurized tube where most of the air has been removed. The operating pressure of the Hyperloop is only 100 Pascal. It reduced the drag force by 1,000 times relative to sea level conditions. Despite that, there will be low pressure air in front of the capsule. It creates an air cushion which will decrease the capsule speed. To overcome this, the compressor fan at the front redirecting air to the backside of the capsule to create extra propulsion force. This results making the capsule even faster. Hyperloop power systems use renewable energy, which will be wind energy and solar energy. It will reduce the fossil fuels pollution of commercial transport to around 50%. It will be accessible to the public in the US by 2022 and worldwide in the future. Till now, I found that these two inventions are indeed beyond our imagination. Without attempts and effort, how do we even know they could actually work? With that being said, our curiosity and innovativeness won't stop us here. There are still a zone of opportunity waiting for us to discover. I'm glad that we are taking one step further towards the pink door. As the technology awaits for us, becoming more than just ideology but a reality. Let us continue until we reach the doorknob. Thank you.